All right. So here we have almost the same idea, but now we've plotted income per person by infant mortality. And infant mortality is the rate of infant deaths. So infants are counted as children under the age of 1. So how many infant deaths you have per 1,000 births. So here we see immediately that there's this sort of, it seems pretty linear. It seems to hug the line pretty closely. And we already know it's nations, right? These are nations. And this seems to be a negative association. And remember, negative in this case means opposites, right? So as one is going up, the other is headed in the opposite direction. So as income goes up, infant mortality goes down. So countries that are very wealthy have very low rates of infant mortality, so they're not losing a lot of infants. Countries that are more poor, where their income is very low, they have a higher rate of infant mortality. And so that's what we think of as a negative association. Oh, I'm sorry, I skipped a step. So that's step 3. Step 2 is shape, and I'm going to write in just linear, because this seems to be even more linear than before. And I would say this is, moderate to strong, because it hugs that line. You could sort of clearly see that line. And let's think about why there might be this negative association. Well, you could think of infant mortality as sort of the opposite of life expectancy, right? So life expectancy, the greater the number, the sort of better the health. Infant mortality, the lower the number, the better the health, right? And so they're sort of, those two ideas are negatively associated with each other. So it makes sense that they would have the exact opposite relationship to income per person. And once again, we might want to think about how variable 1 impacts variable 2, how variable 2 impacts variable 1, and also how a third variable might impact both 1 and 2. And so income might lead to better health care, better prenatal care, and that might lead to better infant mortality. Also, having less infant mortality might somehow help the economy. For instance, having a growth in the population often helps economies grow because they're forced to get more jobs and have more things to serve more people. But also there might be a third variable, again, like war, where war times, often there's more disease, and that might reduce infant mortality and income per person. So those kind of things might be what you want to think about for answer number 5. And I think the Gapminder data set is just really interesting. So you might want to play with the different kinds of axes that you could actually create. And you could create these wonderful scatter plots from real data from the world. You could get, women's education. You could look at other aspects of the economy or health or public policy. And you could look at war. You could look at a whole bunch of different things. All right, example 3. So now we're back to sort of more mundane kinds of statistics problems. Would you expect these variables to have a positive or a negative relationship or trend? Would you expect weak, moderate, or strong strength? Well, these are sort of unlined up, but let's think about the case of chicken eggs. So for each chicken egg, they each have a length and a width. And by length, let's talk about it being the axis of elongation, right? And so that would be like this length, right? And then for the chicken egg, this is the width, right? So would these have a positive association or a negative association? Well, I would imagine that chicken eggs, you might have bigger chicken eggs or smaller chicken eggs, but you don't normally see chicken eggs that are like super skinny or like super fat, right? Like you just have like bigger and larger versions. So I would imagine that length and width are sort of positively associated. And I would probably expect maybe a strong strength, because you almost always see chicken eggs in sort of like one shape, right? So I would imagine that they sort of hug each other closely. Let's talk about U.S. cars. So if our cases were U.S. cars, what would weight and gas mileage look like? Well, maybe it's helpful to just think about maybe a couple of U.S. cars to just help us, think about this. Most U.S. cars, like let's see, like a Hummer, like a crazy Hummer, that's like very, very strong on weight, right? So if we put weight here, that would be like way up here on the weight part. But in terms of gas mileage, the Hummer is not so great, right? So it has relatively low gas mileage, right? Whereas like really light, tiny, tiny little cars, they're less weight, but maybe they have greater gas mileage. But maybe, so maybe we would see something like this. I don't know. Something like that, right? If we plotted all the U.S. cars and their gas mileage. And so here we see something like we see a negative relationship, right? They sort of do the opposite of one another. As weight goes up, gas mileage goes down. And as weight goes down, gas mileage goes up. And I'm not really actually sure how strong of a correlation that may be. So maybe I'll go with moderate. Maybe moderate or moderate to strong. Maybe strong just because I can imagine if you're pulling more weight because your car is big and heavy, then that might bring down your gas mileage. So there might be a pretty strong connection there, but I'm not really sure. So I'm going with moderate to strong. You might know more about cars, so. All right, example 4. Give the trend, the strength, and the shape for the following scatter plots. And let's also throw in consistency, just for ourselves, just to know. This one seems pretty linear, right? Linear and pretty positive. I would say strong. It looks pretty strong. And it seems very constant. The spread is constant down here and here and here. So it's pretty constant throughout. Now this one looks like a pretty weak strength. I don't know if it's a linear. It looks sort of like a cloud to me. I mean, you can draw a line, but it's pretty weak association. The shape we got, if there is a trend, it seems more positive than negative, right? It's because at least there's more up here than down here, more up here and down here. If it was negative, we'd see more here and here. And is it consistent? Yeah, I guess so. It's pretty spread out here, but maybe a little bit less spread out here. So maybe sort of consistent, but a little inconsistent. A little inconsistent. All right, and what about here? Well, this one looks definitely sort of curved to me. So this seems curvilinear. It also seems like a positive association because as x goes up, y is also going up. Yeah, it seems pretty strong, but maybe also a little bit inconsistent because here it seems stronger and it gets a little bit less strong here. But I don't know, sort of consistent. It seems pretty consistent to me, though. So I'll put pretty consistent. This one, I could sort of see a curve, but I could also see sort of a line going through it too. Maybe I'll say curved. But now this is definitely a negative relationship because the low x's have high y's and the high x's have low y's. And it seems maybe moderate or pretty strong, maybe moderate to moderate to strong. And yeah, I don't know, it seems pretty consistent. So I'll go with constant. And here we have a quite linear negative, and it seems I don't know, this seems pretty strong too. Let's go with strong. Yeah, notice that these are all very like, I'm sort of eyeballing it. And it seems consistent. So this is just a way to just help us just eyeball these a little bit better, get used to seeing them, get used to seeing some of these features in them very quickly. So yeah, that's scatter plot.